machines as well as the programming part. So one part is the fundamental, another is the real activity which we people, manufacturing people execute with the machine in the shop floor or in the laboratory. That is the programming part. Basically, this is a manufacturing system where we convert the raw material into a finished component depending on the attributes already specified in the drawing, because for any manufacturing, drawing is the input. So all the technical details regarding the height, shape, dimensions, tolerance, surface finish, these are the mechanical attributes which are common between the mechanical items. Those are specified in the drawing, and what is specified in the drawing, that is really actually taken care of while preparing a program in a coded instruction form. That will be executed in an unmanned environment so that raw material can be converted to the finished component to conform to the drawing specifications. That is the requirement. And before going to the NCCNC detail, let us have a initial discussion on the very fundamental concept, that is the mechanization and the automation. Quite often these two terms, irrespective of the mechanical or EI or EC, we talk about quite often mechanization and automation. But what exactly it is? The term mechanization was evolved during the first second industrial evolution to consider that how human effort or human muscle power can be replaced by the power of non-living systems. Because in the earlier time or ancient times rather, there was no mechanical device or no electrical power. So people used to utilize their muscle power to carry out some sort of work, mainly for fetching the food or to carry out some other activity. But that is not sufficient. That is not effective to achieve the desired target. So that was the driving force when people started, or the researcher or the scientists people started thinking how the power of non-living systems can be utilized to ease our functions. And that is how, for the last several thousands of years, different development that we can see right now is the basically output or contribution which is popularly known as the mechanization. So the objective of the mechanization to replace the human muscle power to get the work done by non-living system. Let us take a very simple example. All of us either use some bikes or cars. So in this particular car or automobile or in the bike, the power is developed by an engine, that is obviously non-living system. So chemical energy present in the fuel, that is burned, mechanical is converted to the mechanical energy, and through the power transmission system, it helps to propel the vehicle. So it is not the muscle power of the human being, just like a manual rickshaw, but physical human power is utilized. So if you compare it with an automobile, so here some non-living system power is utilized to propel the vehicle. So that is how we can save or replace the human effort. And obviously, the output level is much better as compared to a manual driven car or rickshaw. So the basic source is in case of electromechanical devices, because majority of the devices that we use for mechanical work, these are fundamentally all belongs to the electromechanical device. So initial or the source is electrical energy. If you think about a pump, if you think about a refrigerator, if you think about this fan, that is also electrical to mechanical conversion. Or machine tool, car. So everywhere you find that your source is electrical energy. So this electrical energy is subsequently converted to mechanical energy. In case of pump, it is further converted to hydraulic energy to lift the water from the ground level to the desired height. So that is what exactly is the mechanization. Automation, a little bit advanced stage of mechanization. When this area is more or less fulfilled, then people started thinking how, in addition to the human muscle power, how the brain power also can be replaced by some non-living systems. And that is how the intelligent decision making or intelligent machines came into existence particularly in the 1960 onwards, when digital electronics and computer came into existence, and subsequently it was proliferated in 1980. So in automation, what is the key concept? In addition to the replacement of the muscle power or the motive power, the brain power or the decision power is also taken care of by the non-living system. Again, returning back to the same example of the automobile. So, what is the role of the driver? So, it is the engine that develops power by burning fuel and it helps to propel the vehicle. So, what is the role of the driver? Who drives the vehicle? It is the decision. Just say fundamentally, it is decision making. How to steer, whether in left or right, when to apply accelerator, when to apply brake, when to apply clutch. So, these are all basically decision making. So, in the machine that you had worked in the ideal lab, we have seen that it is carried out without any operator or human intervention. So, it is in the form of a coded instruction residing in the computer that is interpreted by the machine control unit. That is, it is also non-living system. So, their non-living system also taking the decision how to guide the tools so that your desired geometry can be operated. Cutting is mechanical. So, as far as the cutting part is concerned, rotation part is concerned, movement part is concerned, that is mechanical. But in which direction, whether it is straight line path or a curvature path or a point, in this direction, to what or to what distance, these are all basically decision. So, when in addition to the physical part or physical activity, when decision making activity is also taken care of by the non-living system, then it is called automation. So, in our technical fraternity or instrumentation or electrical fraternity, this is popularly known as control. So, one is basically actuation, another is control. So, in case of a human living system or any other living system, all activities that we perform, it involves two different activities. One is physical part. I am speaking by using of my face, by moving my hands, I am moving on my legs, I am playing football, I am playing cricket. All are basically physical activity. But decision is taken care of by the control. To what extent I move, in which direction I will move, at what speed I will move, everything is decided by brain. So this brain power is nothing but a control, and that is what exactly is when implemented in the non-living system, that is automation. So quite often we talk about your automatic washing machine. What does it imply? So in addition to your basic function, that is there is a popular it rotates, it spins, and with the help of your caustic soda and water, it washes the garments. But at what speed to rotate? How long? When to stop? When to give your period? Drying part, when to switch over? All are basically PLC microcontroller. So this controlling part is basically automated. So automated device will have some decision making power. So as far as this, why I am talking so, in case of CNC, computer numerical control. So the main thing is on the control, and how it is taken care of by means of some numerical values or numerical codes. Truly speaking, it is alphanumeric control. If you have a glimpse of the any particular program, even if you do not understand, but if you scan it, you will find that it contains some alphabets from A to Z. Everyone has, or every alphabet has got its own meanings, followed by some numeric values. Say G01, G04, M06. Always start with some alphabet followed by some numeric value. So these are some sort of coded instructions that we will discuss in detail when we talk about the programming. So, but essentially, it is numerically controlled, but truly speaking, it is alphanumerical control. And in the first slide, I have mentioned NCCNC. Initially, when digital electronics was not so popular, at that time, and there was no computer, it was only hardware electronic circuit to control these functions. That is why this generation of machines was started with numerical control. In 1956, first AC machine was developed at MIT because of NC nature. But afterwards, when digital electronics and computer there has been tremendous development, so all these NC machines were subsequently replaced by computer numerical control, and of course some other augmented facilities or the devices were developed, like robotic system. That is also a computer control system. in today's world, all the industrial robots which are available at our disposal or which are used, those are also basically controlled by these are numerical codes. To carry out some other activities like material handling, prominently inspection, spray painting, which are mostly hazardous activities. In that case, our human worker are now increasingly being replaced by industrial process. So control is the basically automation refers to the use of non-living systems to execute intelligent or decision-making functions without human intervention. That is replacement of brain power by non-living system. Here it was muscle power. In this case, it is brain power. That is the control part. Okay. So that is the key difference between the mechanization and automation. Now, automation can be of two categories. One is hard automation, another is programmable automation. Before computer, there was also automation. Not that automation is only related to the computer or the electronics. In before 70s, earlier, particularly the machine tools that we use for manufacturing or production purpose, there are also some automation, but this control was executed by some mechanical devices. Those devices are cam, limit switch, clutches, locks, etc. So it has got automation, but it has got certain limitations. And the purpose of automation was at that time to boost or to increase the productivity. So in this context, I will just without going to the technical details, let us discuss a little bit on the background of the why this hard automation and programmable architectural automation are required. Both are related closely to the business perspective or business perspective. In the earlier days, maybe in the 1940s to up to 60s or early 70s, the business was prominently governed by mass manufacturing. It is what is mass manufacturing? Number of variants or number of competitors were less. For any particular product, there would have been maybe one or maximum two manufacturers. So that implies the market is almost monopoly. In the absence of competitors, since if I am the only manufacturer of say or any particular brand of automobile, people irrespective of their financial status, whether they can afford one crore car or they can afford only 2 lakh rupees car, there is no option to buy very costly or different variants of cars. So in our childhood, how many next is that in our childhood we had seen only Ambassador or Maruti 800. That was the only car which was available, more or less. But now you take a rise to like 100, more than 100 variants are available from wide number of manufacturers. 10 to 12 very popular manufacturers are there. Be it in the lower segment, Maruti, Hyundai, Tata Motors, maybe Toyota is there. Very high cost brand, you will find Mercedes-Benz, Volkswagen, Audi, Mercedes, BMW. These are also available in India. So now, and in between, so price varies from 3 lakhs to 3 crores. So why is it? That means wide varieties of customers are available in the current days, and wide spectrum of models of the products are also available. So depending on my pocket, depending on my taste, depending on my choice, I can select any particular brand suit my requirement. But this was not prevalent in before 1960s. So at that time, since only one manufacturer is there, say for instance Ambassador, and no other competitors are there, so more philosophy was more you produce, more will be sold to the market, and more profit and revenue that organization can do. So the objective was how to economize the production, how to boost the productivity, so that I can cut down the production cost, so that more and more will be produced and it will be sold to the market because there is no competition. So in that case, those initial machines I have mentioned, that automatic, these machine tools are extraordinary machine tools with some added feature to take care about the automation, which was utilized to cut down the unproductive time of the machine and to avail the uptime so that more productivity can be expected. The total time that we consume while carrying out any operation, it has got two components. One is uptime, another is downtime, or sometimes we call unproductive time. Uptime is the real time which is available for carrying out useful work. If there is some failure or bottleneck or breakdown, so you cannot work with the machine unless it is repaired and put it to operation. So that time is called downtime. And even if it is the uptime, some portion is real productive time, some is unproductive time. But the unproductive time, actually, so long the tool is in contact with the job, you have seen, just try to correlate what you have seen. The cutter is continuously cutting. So long there is advancement of the progress of the cutting, that is really productive time. Sometimes you have seen that it is moving away, moving up, then moving to the next second position, it gets some amount of depth of cut and then starts cutting. So these two three movements are basically unproductive time, because there is no cutting taking place. Or it may also happen for a real mechanical component, more than one tool is required. So tool changing, one tool to other tool changing, that also takes some amount of time. So that is also unproductive. Right? So here unproductive does not necessarily mean that operator is absent or operator is not participating. It is not like that. So objective should be that unproductive time should be as low as possible, so that your real productive time increases and automatically your output of the productivity increases. So that is how it is called hard. Why it is called hard? Because of the fact those mechanical items introduced for the design and construction of the machine tools, those are fixed. That is dedicated for one particular purpose. So keeping its end objective in mind, that particular cam profile is very complicated, and it is exclusive for any execute any particular motion. Suppose a to and fro motion will take place between two profiles, let's say 100 or 150 millimeter. Now, for depending on the change in the job, if you would like to change that this 100 millimeter to and fro motion would be modified to 50 millimeter, which is not in the same time. The entire thing you have to change. That is a very costly affair. So that is why it is called hard and rigid. It won't permit or offer any flexibility to switch over from 100 to 100 or to 100 to 50 or to 50 to say 175. So this variation is not possible. And this variation requirement was also not required at that particular time, because there is no change in the product. So objective is same product, try to produce as fast as possible without go for any changes. So to reduce this idle time or unproductive time, this initial level of hard automation was required. But the business philosophy has changed after 90, after globalization. Now it is a global market. So any manufacturer all across the globe can execute their business anywhere in the world, and that is why that Mercedes-Benz, BMW, Toyota, they are all basically from the outside, from the abroad, but they are making business in India. No, there is no such restriction. So in that case, you just see what is the how much difficult or how much is the challenge. Those who are Indian manufacturers, they will have to compete with the brand manufacturer like Mercedes, where their credentials are well established over the decades. So unless and until you uplift your modus operandi of the performance of the technology or then the engineering, it will be very difficult to compete or to sustain in the highly competitive global market. So in that case, what will facilitate how to survive in the market? You have to change your control structure. So initial high productive machines need to be replaced by the flexible switch over to the machines which relies on the programming. Because in case of CNC type of machine, you need not to go for any hardware changes. Only depending on your job change requirement, you just change the software in your program, and the same machine will be able to deal with the new geometry or the new configuration. So that is what exactly we can utilize as a programmable automation. So there are two key features or key attributes which are related to our productivity or management or any business. One is productivity, how much or we can produce, that's the quantity, and flexibility refers to how we can accommodate changes. Today I am manufacturing or our facility are utilized for manufacturing this mobile. It may require that after 15 days I will have to switch over to this brand. After 10 days it may be required to switch over to that particular brand. But it does not mean that every time I will invest crores of rupees and will buy new machines. Same machines, but simply by changing the program, the machine should be able to cope with the different ideas. Of course, there will be limitations. There will be some ranges. We cannot expect that tomorrow Maruti will be able to manufacture aircraft. Okay, so within the range of automobiles and small car, they can come up with new product or new models. Every year that is happening in your daily, that is the automobile fair, normally daily January, February. So all the leading manufacturers are coming out with their new ideas, just to showcase their new product which are coming to the market. But in the same segment. Okay, so that is the what is called programmable automation or flexible automation. So this CNC machine tools falls under this programmable automation category. Similarly, robots as well as I was talking about, robots is also programmable. CMM it also based on the principle of this same CNC, but instead of cutting, it is used for inspection of the measurement. In our traditional approach to measurement, if I am interested to measure its dimension, I will use some micrometer or vernier caliper to measure. But if you want to go for a very sophisticated one, then if you do have CMM at your disposal, then that can be measured. There is a probe. That probe is just like a CNC having courier system. That probe will make a touch stick as well. It will make a contact. A spherical small ball is there made of sapphire. Okay, just to reduce the wear and tear. So it will make a contact and this courier is recorded. And again it is shifted and make another contact. So if the courier of these 2 points are known, certainly by using the very fundamentals of courier geometry, you can measure this distance. So that is the principle of CMM. But fundamentally, it relies on the principle of PLC. So as far as this numerical control is concerned, according to EIA, that is the Electronics Industry Association, they have defined it is a system in which actions are controlled by the direct insertion of alphanumeric data at some point of time. The system must automatically interpret at least some portion of the data. By the apparently it seems that this last time will show or give you the idea or feelings that it is something incomplete. A some portion. How much portion? 40%, 30%, 10%, 90%. Actually, this definition was developed very early stage. At this time, people did not imagine or did not forecast what would be the extent of activity this unmanned system will be able to perform. So, if some portion is also possible, then we can say that some portion or some activity can be automated by this numerical process. So, where as I was talking about this alphanumerical data, which is popularly known as CNC course, perhaps you had a glimpse in the idea lab. The system must automatically interpret some portion of this data. So, the entire program should be written following some definite syntax. It should appear in a logical manner according to your nature of the complex or the shape and size of your the component. And what essentially includes a part program includes toolbar, process variables, and some auxiliary functions. If you visualize what you have carried out the operation CNC router in the idea lab, you will find this tool is moving something like that according to your job geometry. So that is basically tool path. That is the path along which that tool is navigating in space. So that should be taken care of or should be captured in your board. Of course, with your coordinate points, process variables. There are 3 prominent variables in metal cutting. That is, one is called speed, another is called feet, another is called depth of cut. Just what is speed? You will find one cutter that is rotating at any RPM. So that is tangential velocity. That is B equal to pi dl, depending on the diameter of the cutter and RPM. That velocity is called cutting speed. Okay, this cutting speed is important, not the RPM. That is one regulating factor. Feet means advancement rate. That is a linear velocity, millimeter per minute. In some case, we define as a millimeter per revolution. That is in case of blade category machine. But in the CNC router, it will be expressed in millimeter per minute while rotated. And depth of cut, some of the end of thickness of the sheet or plate that you are cutting, maybe 10 millimeter. So suppose you would like to machine up to 5 millimeter depth. So the cutter may not be able to apply 5 millimeter depth of cut in one go. Otherwise, cutting force will be significantly higher. So in that case, 5 millimeter may be divided into 2.5 to 2.5 twice or 2 to 1 according to your choice. So that particular parameter is called also depth of cut. So these three together in the cutting of areas are captured by process variables. What is auxiliary function? This RPM that is identified as an auxiliary function. Tool path is this motion in the horizontal x-ray plane, but this rotation that is treated as a auxiliary function. Another thing that is also popular but was not required for this router, that is basically in case of machining steel, okay, tremendous heat generation takes place. So to cool the job, that will adversely affect high temperature job geometry, and most importantly, that will adversely affect the life of the cutting tool. So this cutting tool is also replaceable. With the passage of time, it wears out, and depending on the operating variables and duration, you have to replace it. Just like our knife, we resharpen after a certain time of period of time. That is we call VR. Okay. So that to pull the job and to pull the tool and to wash away the chips which are coming out, we need to pour a supply high speed coolant at the tool chip interface, so that the chip will be eliminated and it will help to cool down the job as well as the cutting. Okay. So in that case, this automatic function of applying the cutting oil comes under auxiliary. So in essence, all sorts of activities, whether it is tool path, process variables, auxiliary function, all are captured within that NCCNC code. That is popularly known as the entire thing is known as part. Okay. This is not exactly required for it. This basically the retrofitting concept was associated with the NC. When people started developing how NC machine will be different from a conventional machine. That is, if you want to upgrade a conventional machine to an NC machine, then what are the steps to be taken? So that activity is also popularly known as retrofitting, which requires that each axis motion has to be accomplished by separate closed loop control system. Just one thing I am telling, in conventional machine tool which are available in the workshop, it has got only one motor or only one power source. And through mechanical arrangement, power is diverted to a different area. But in NCCNC, for each axis motion, so if you think about the XY movement, so long tool is moving like this in far, so it is interpolating in XY plane. So there are two drive systems, one along X, another along Y. Similarly, for up and down movement, there is another axis. So each axis motion is accompanied by separate control board, having a separate servo motor drive. That is the first point. Second point is basically for any conversion of particularly the mechanical domain, it is very common. The rotary motion needs to be converted to linear motion. Very simple example, simply take one nut and bolt. Whenever you fasten one nut and bolt, we impart rotation, and as a result, this linear motion is converted to rotational motion is converted to linear motion. So in machine tool also there are needs to which is required to convert rotational motion to linear motion. But that needs to is modified, is augmented with a different form which is popularly known as recirculating balls. Okay. So within the spiral groups, some small like bearing type of balls are there. The main fundamental concept of the mechanics is that unless the earlier one, sliding friction is converted, modified by or replaced by rotary friction. But coefficient of rotary friction is much less as compared to the linear friction. So that improves the transmission. Another source of frictional loss, while undertaking sliding motion. That is very common, they cannot avoid it. But to reduce it, it is recommended that drivers should be coated with a polyfluoroethylene compound, which will reduce the possibility of stick slip motion. And on NC console, that there will be a operator console that we are seeing, that is the part and parcel of the NCCNC. So at least these four activities we have to